We are studying arithmetic progression, which is chapter number 3 in Maths 1. Today we will learn about a new thing about arithmetic progression, and it is the concept of sum of first n terms. Sum of first n terms of a arithmetic progression. How will our session look like? Our session will have 3 parts. First, it will be a recap. Recap is revision, relook. The recap will be about the nth term of AP. Nth term of AP, which we studied in the last to last class. And we practiced it more and more in the last class, right? Then we will learn about the sum of first n terms of AP. And finally, we will practice about the sum of first n terms of AP. 3 parts. We will try have a short break in between. But again, it will depend on how we proceed in the class. How much you participate, how fast we are, everything, all these things will decide whether we will have the time for a break or not. Can we begin? Are we ready? Okay, we are ready. Let's begin with the recap. Let us try remember what the formula for the nth term of a AP is. How do we calculate the nth term of AP? Can someone come out of mute and tell me the formula? And yes, you are allowed to use your textbook. Or if you are more comfortable typing it in the chat, type it in the chat. What is the formula for the nth term of AP? Thank you, Karthik. Thank you, Prachi. Right? Karthik and Prachi, you have given me the 2 formula that I was looking for. Thank you, Sandhya, but you have mistyped. So the 2 formulae that we studied in the context of nth term of AP are, first one, Tn. Tn means nth term is equal to T1 plus n minus 1 into D, where D is the common difference. And the second formula, in place of T1, we can also say A. Tn equals to A plus n minus 1 into D. If I was teaching you using a textbook that I would have written, I would have had only one formula, and that is the first one. Tn equals to T1 plus n minus 1 into D. In our textbook, for some reason, another formula is given where T1 is shown as A, and another formula becomes Tn equals to A plus n minus 1. That's the only thing. There is no other difference. In terms of values, in terms of mathematics, it's all same. So thank you, Aman, for sharing your answer. Thank you, Aarti Bania, Chanda, Tushar, all of you for sharing the answer. Good. We will need this. We will need this to solve questions, even in practice set 3.3. Note down these 2 formulae in your notebook for today before we move forward. Once you have noted them down, confirm with a thumb up. Okay. So if we know that these are the formulae for the nth term, let us see some questions. We already solved a lot of questions in the previous class. Let us look at some other types of questions which were there in the example and which were also there in the practice set 3.2, which was part of your homework. Right? This is example number 1. It says, why should I read? Who will read? Raise your hand. Be fast. Yes, Tushar, go ahead, read.
Find T for following arithmetic progression and then find 30th term of arithmetic progression.
Okay, Tushar, you have read, but you have not read it completely. The complete question is, find Tn, that means nth term for following AP. We can call it AP. We need not say arithmetic progression all the time. Find Tn for following AP and then find 30th term of AP. Which is the AP? The AP is 3, 8, 13, 18. Tushar, you forgot to read 3, 8, 13, 18. I will explain this question to you, and then from next question onwards, we will see how much you have understood, how much you have not understood. Keep your textbooks open, ask your doubts if required. This is a solved example in the textbook. I hope you have found where it is. It is on page number 64 of your textbook, solved examples, question number 1. Right. So first, there are two parts. First part is find Tn for the following AP. We know that Tn equals to T1 plus n minus 1 into D. So to find Tn for this AP, what we need to know is T1 and D. Here, T1 very clearly is 3, first term. And our D is the common difference, which is 8 minus 3 equals to 5. We know this already. So when we put T1 is equal to 3, n minus 1 as n minus 1, and D as 5. Till now, this is arithmetic progression question. From here onwards, it becomes a algebra question. So when we simplify this becomes 3. 5 into n is 5n. 5 into minus 1 is minus 5. We can simplify this. 5n is 5n. 3 minus 5 is minus 2. So we can say Tn equals to 5n minus 2. The reason I'm explaining this question, all these questions to you is, doing this, honestly speaking, is in most cases a non-value adding step. There is no value in finding out this formula because this formula is more than enough. But what this question is asking us to do is to write the formula for Tn for this particular AP. That is the question. Don't think that for any question we will have to convert this. No, we don't need to. We will see it right now. This is the first part. Now the second part is to find the 30th term of AP. Now we know Tn, so we have to find T30. So I'm skipping a few steps. We can write T1 we know is 3 plus n is 30. So 30 minus 1 and our D is 5. So we can calculate our T30 as 3 plus 29 into 5. So 3 plus 145. Is it correct? Which is 148. Do you think this is correct? Check your answers. And please confirm. Waiting for your confirmations. That you saw what I have done on the screen, that you have understood what I have done. Now, what the value we have to add to by attending this class is, and why is the textbook solving the way it is solving? What the textbook is doing is, instead of using the general formula, I used the general formula to solve this. The textbook is using this formula, the specific formula, the formula which is only for this AP, which is Tn equals to 5n minus 2. So if we say Tn equals to 5n minus 2, T30, which is the 30th term, will be equal to 5 into 30 minus 2, 150 minus 2 equals to 148. This is what the textbook has done. What we need to understand is this question can be solved in multiple ways. If we use the general formula, this is the method. This is the formula that we will use. If we use the specific formula, this is the method we will use. Example number 2 is another type of question. Who will read it now? Raise your hand and be fast. Aman, please go ahead. Unmute yourself. Read it.
Which term of the following AP is 560, 211, 20, 29?
And Aman, there is dot, dot, dot. This is an infinite AP. Thank you, Aman. Right. Now tell me, in this question, what is it that we have to find out? Do we have to find out the AP? Do we have to find out the common difference? Do we have to find out the first term? What is it that we need to find out? This was homework, right? You were supposed to study, understand, solve, ask doubts. Nothing happened. What is the question asking us to find? Aman, you are just using the words which are given in the question. I'm telling you how the type of answer I'm looking for, the type of answer that we need to come up with. Is it asking us to find the AP? Is it asking us to find the first term? Is it asking us to find the common difference? What is it is asking? No, Akhilesh, Rajesh, it is not asking us to find the term. No, Chan, we don't have to find the sequence. Tushar, when we say which term, that is what it is saying, which term. How translate into maths. Anushka, the term of the number. Yes, that is the term of the number. But what does it translate into in mathematics? Use the words, use the language of arithmetics. What do we have to find? Okay, I'll give you some options. You tell me what we need to find. Let us see. I'm writing the options on the screen. The options are correct. No, not correct enough answer. The options are A, T1, AP, D, Tn. What is that we need to find out? Or maybe N. What do we have to find out?
N.
Yes, Tushar, now it is correct. We have to find N, not Tn. We have to find N. And this is what we need to understand. When we say which term, this is just English. In mathematics, it translates into N. We have to find the N. And now we can use our maths to find out the N. Good. You have identified what we need to find out. Let us see how we can do this. So very clearly it says 560 is a term of this AP. माने कहीं पर है 560. We don't know which term it is, but what we know is this is T1, this is T2. So we can say let 560 be the nth term. Now we know that Tn is T1 plus n minus 1 into D. We just said that let 560 be Tn. Okay, 560. Tell me, what should I write here in place of T1? Unmute yourself and speak fast.
560.
No. Correct answer is 2. 2 is correct answer. N I don't know. I need to find what is D. How much is D?
9.
How did you find it out?
Second term minus first term.
11 minus 2 is 9. Right? Now you see, this is, what is this? What is this called in mathematics? 560 equals to 2 plus n minus 1 into 9. What is this called in mathematics? Akhilesh is saying equation. Yes, it is an equation. Be more specific, Akhilesh, Rajesh. Prachi, yes, it is a linear equation. Agreed. Be more specific. It is an equation. Agreed. It is a linear equation. Agreed. No, it is not a polynomial. Tushar, yes, it is algebraic equation. Be more specific. Very good, Prachi. It is linear equation in one variable. Very good, Jan. Linear equation in one variable. So all we need to do now is use algebra to find n. Use algebra to find n. That means we have to solve. We have to solve this equation. When we solve this equation, we will find the value of n. That is it. Example number 3 is another type of question. These 5 examples that are on page number 64 and 65 are very nice examples. They cover all types of questions, almost. Who will read this question? Quickly. Raise your hand. Yes, Muskan or Sania, unmute yourself and read it.
Check whether 301 is in the sequence.
Okay. Once again, you also read the question. You did not read the question completely. The question is, check whether 301 is in the sequence 5, 11, 17, 23. We have to read the sequence also. When we read the question incorrectly, what we understand from that is we haven't understood what a sequence is or what an arithmetic progression is. Right? Let us learn from our mistakes. Let us observe how we are studying, how we are answering, what we are saying, and learn. But keep trying. Every time we try, we learn something new. Okay. So here, a sequence is given 5, 11, 17, 23. And we have to check whether 301 is in the sequence. Tushar is so fast. Tushar is answering not in the sequence. We have not reached there, Tushar. There are a few steps. We have to ensure that we have understood the steps before we answer that question. Question number 1. What is this? Is this a sequence or an arithmetic progression? Whoever knows, you can type the answer or you can unmute yourself and answer. Is this just a sequence or it is an arithmetic progression? Prachi is saying we will have to find out. Very good. That is the first thing that we need to notice. In the question, it is not given that this is an arithmetic progression. It says it's a sequence. So how will we find out? Chand is saying it is an arithmetic progression. How, Chand, how did you find out that this is an arithmetic sequence? Tell me, how will we find out whether this is an arithmetic sequence, arithmetic progression or not? By seeing the common difference. Yes, correct. So what we need to do is, first step, an essential step. This is T1, this is T2, this is T3, this is T4. We have to find T2 minus T1, T3 minus T2, T4 minus T3. Remember what I said. Always try to find all the differences, possible differences. So T2 minus T1 is 11 minus 5. T3 minus T2 is 17 minus 11. T4 minus T3 is 23 minus 17. All the cases, it is 6, 6, 6. Because all these are equal, we can say that the difference is common and 6. And because it is this, so we know, yes, AP. This is arithmetic progression. Yes, this is arithmetic progression. This is the reason why we need to do this, because in the question it says this is a sequence. Now tell me what we need to do. In the previous question, we had to find n. What do we need to find now? What do we need to do in this? What is the main question in this? What is the main thing that we need to do? Chand is saying we have to find n. No, that is not the case. Prachi, you have answered how we will do it. My question is very, very simple. Very good, Satyam. All we have to find, and someone else also replied. Just let me see the name. Alfia. Yes. All we need to do is, now we need to see if this is an arithmetic progression, can 301 be part of this arithmetic progression or not? That means, is 301 a term? So that is where Tushar, when he says, we need to find out whether 301 can be Tn. So we will say our Tn, let 301 be Tn. Tn. We know Tn equals to T1 plus n minus 1 into D. Our D is 6. Our T1 is 5. And we will try to find out our Tn is 301. So क्या हुआ equation? 301 equals to 5 plus n minus 1 into 6. What is this once again? This is a linear equation in one variable. Now, if we are able to solve this equation and if we find a valid value of n, agar n 10 aaya, okay. If we find n to be 200, that is also okay. If we find n to be 100 or 1236, that is also fine. But if we find n to be 1 by 2, if we find n to be 2 by 3, if we find n to be minus 66, it is not possible, because term can be 1, 2, 3, 4 natural number. So we have to solve for n, understand what type of value n is, and then decide whether 301 is a part of the sequence or arithmetic progression or not. The next question, which is example number 4, is very simple, short question. How many 2-digit numbers are divisible by 4? How many 2-digit numbers are divisible by 4? So what you are going to tell me is the smallest 2-digit number. Tell me what it is. Smallest 2-digit number. Speak or type. Correct answer is 10. Thank you. What is the largest 2-digit number? Very good. It is 99. Right? The questions have not ended. There are 2 more questions. Tell me the smallest 2-digit number divisible by 4. Smallest 2-digit number which is divisible by 4. The smallest 2-digit number is 10, but 10 is not divisible by 4. Is 11 divisible by 4? No. It is 12. Now tell me the largest 2-digit number divisible by 4. So we have to start from 99 now. Is 99 divisible by 4? No. Is 98 divisible by 4? No. Is 97? No. Is 96? Yes. It is 96. Ankit is saying 90 is divisible by 4. Check again, beta. Is it really divisible by 4? Divide and see. Yeah. 98 is not divisible by 4. So for the smallest two-digit number divisible by 4, we start from 10 and check. For the largest two-digit number divisible by 4, we start from 99, go backwards and check. Now we don't need this. Now we don't need this. We need 12 and we need 96. From here, we know that the AP that we are dealing with is 12. What will be the second term of the AP? Tell me or type it. What will be the second term of the AP? How many 16 plus 4 plus 4, है ना? Dot, dot, dot. What will be the last term of the AP? 96. What type of AP is this? Is it finite AP or infinite AP?
Finite.
It is finite AP. It is finite AP. Now, if we have converted this English question into AP mathematics, now look at the question again. It says how many two-digit numbers are divisible by 4. Now tell me, what do we need to find out? Do we need to find out T1? Do we need to find out Tn? Do we need to find out A? Do we need to find out D? Do we need to find out N? What do we need to find out?
N.
N, number of terms. And we already know the formula. Tn equals to T1 plus N minus 1 into D. We know T1, we know Tn, we know D. So this converts into another linear equation in one variable. 96 equals to 12 plus N minus 1, and our D is 4. Dekho, 4. Solve this and you will find out. So here we have used arithmetic progression to find number of numbers, number of two-digit numbers that are divisible by 4. Next question, example number 5. It's not difficult, but again it will use a lot of algebra. It says the 10th term and the 18th term of an AP are 25 and 41 respectively. Okay? A lot of English. We need to know the meaning of the word respectively. Respectively means the 10th term is 25. Respectively means the 18th term is 41. This is the meaning of respectively, not the other way around. Then we have to find the 30th term of this AP. Which AP? I don't know. We don't know. We have to create that AP. We have to understand that AP. Remember, any AP is formed of just two things: first term and common difference. And once we have found that, we have to find the nth term. Okay. Another question. The nth term is 99. Find the value of n. It looks very difficult. It is not. We have to find and we have to form an equation. We have to convert this into maths. So 10th term is T10. 18th term is T18. 10th term can be written as T1 plus 10 minus 1 into D. 18th term can be written as T1 plus 18 minus 1 into D. Correct? Now what are these? We know T10 is equal to 25. We know T18 is equal to 41. If I tell you this is 1, this is 2, what do you see on the screen? Speak or type. What do we have now? We have converted this question into what? Okay. Equation is correct. Be more specific. Chand is saying linear equations in two variables. Yes. The two variables are T1 and D. We can use any method we want. Substitution, elimination, determinant, graphical, whichever. is easy for us, most comfortable for us, we can use the method of solving linear equations in two variables to find the values of T1 and D. T1 and D. And once we have found out the values of T1 and D, we have found out the AP. Once we have found out the AP, 30th term पता नहीं कर पाएंगे आराम से T38. Use the formula, use the value of T1 and D. Nth term is 99, तो हम क्या लिखेंगे? 99 equals to Tn equals to formula लिखेंगे and we will find the value of n. And exact same logic is used in the solution. We form a linear equation 1, 25 equals to a plus 90. We form another linear equation which is number 2, 41 equals to a plus 17d. Now it has used the substitution method to find out the value of d and then find the value of a. Once that is found out, using the formula for nth term, T38 has been found to be 81. And then finally, by taking 99 as the nth term, the value of n has been found to be 47. That means 47th term is 99. This is question number 5 of practice set 3.2 that was part of your homework, where it says find the 27th term of the following AP. So the AP is given. We had to identify A and D, and then using the formula of Tn, we had to find 27th term. So T27 we had to find it. T27. Moving on. Question number 6 of practice set 3.2. It says how many 3-digit natural numbers are divisible by 5? So remember, the 3-digit natural numbers start from 100. They go all the way up to 999. It says divisible by 5. So the smallest 3-digit number that is divisible by 5 is 100. 100 is divisible by 5. It continues. And it continues till 995. Just like the example question, 2-digit numbers divisible by 4. It is 3-digit numbers divisible by 5. Same logic. Clearing the screens. Question number 7. This is just like example number 5. 11th term is 21. 21st term is 29. 11th term is 16. 21st term is 29. We have to find the 41st term. In the question, it should have been written 41st. 41st like this, not 41th. This is correct, strictly speaking. 41st. Clearing the screen. So now question number 8 of practice set 3.2. Here we have to find n. AP is given 11852. It's a decreasing AP. Which term is number 151? Here we have to find the value of n. We have this type of question is also there in the example. Question number 9. Natural numbers from 10 to 250, how many are divisible by 4? No problem at all. We know the numbers are 10 to 250. We need divisible by 4. So it starts from 12, then 16, then 20, and it continues till 240 what? 8? Yes, 248. So we know T1, we know Tn. We can find the value of n. How many numbers are there? Clearing the screen. Question number 10 of the AP. In an AP, 17th term is 7 more than the 10th term. Again, 17th term is T17. We will have an equation. 10th term, so T10. 17th term is 7 more than the 10th term. Matlab T17 equals to T10 plus 7. So we can connect equation number 1 and equation number 2. We connect that and we can find the value of T. The new thing, the next concept in AP is the sum of first n terms of AP. We know AP. We know how to, we know what the first term means. We know what the nth term means. We know what the common difference means. We have looked at different types of questions where we were able to find nth term. We were able to find whether a given number is part of the AP or not. We were able to find the number of terms in the AP. All this we did. The second concept, the next concept is how do we find the sum of first n terms of AP? Don't worry, you will understand what it is. If you remember, I had explained to you, we have understood a concept called series. First, we understood the concept of a sequence. Then we understood the concept of a series, where we understood that a sequence can be written like this: 1, 2, 3, 4, 5. Can you give a special name to this arithmetic progression or this sequence? This is a sequence and this is an arithmetic progression also. What is the special name for this arithmetic progression? 1, 2, 3, 4, 5, dot, dot, dot. It has a special name. You know it. Starting with a D. They are called natural numbers. Correct, Anushka? They are called natural numbers. Now, what is the common difference in this arithmetic progression? Quickly calculate and tell. No, don't even need to calculate. You know this already. It is 1. 1 plus 1 is 2. 2 minus 1 is 2. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. Okay. Now, remember, when we take the sum of the numbers in a sequence, whether it is a AP or not, it is called a series. Do you remember this? Difference between sequence and series, difference between a progression and a series. When we take the sum of the numbers in a sequence or a progression, that is called a series. But here, the concept of sum of first n terms, it is not a series, because it is not saying take the sum of all the terms. It is saying take the sum of, say, first 5 terms. 1, 2, 1 plus 2 plus 3 plus 4 plus 5. This is the concept of sum of first n terms of the arithmetic progression. See the connection. See the connection between the arithmetic progression and the sum of first 5 terms. 1, 2, 3, 4, 5. If it was for some other terms, right? If you are writing it in general, then we use the symbol Sn. Sn means sum of first n terms, which will be equal to T1 plus T2 plus T3 plus Tn, where T1, T2, T3, Tn are terms of an AP. This is the meaning of first n terms of an AP. In this particular case, where the AP is 1, 2, 3, 4, 5, and so on, the sum of first 5 terms is 15. Very good. We can also write the formula for sum of first n terms in terms of A. So in place of T1, we can just write A, because T1 is also written as A. Not a big deal. Before we understand how do we find out the sum of the first n terms of the arithmetic progression, please try note down. Remember that these are the 3 formulas that are given in the textbook. 3 formulas. Sn can be calculated as n by 2 within brackets 2a plus n minus 1 into d. Then it can also be calculated as n into a plus n into n minus 1 by 2 into d. It can also be calculated as n by 2 within brackets t1 plus tn. These formulae are given in the textbook on page number 69 and 70. Have the textbooks open. Tell me when you are ready. We are going to use this formula right now, when we will not have it on the screen. Now let us try use those formulae to find the sum of first 20 terms of this AP. The AP is the same AP, 1 plus 2 plus 3, well, not plus, it is 1, 2, 3, 4, 5. So first thing that we need to do is just do a simple addition, find this sum. What sum? 1 plus 2 plus 3 plus 20. Find it and tell me how much is it. Do the simple sum and tell me. So if we have a simple AP, which is 1, 2, 3, 4, 5, this is an infinite AP of natural numbers. And if we have to calculate the sum of the first 20 terms, we can just do the addition, and we found it that it is 210. Can we do it in some other way? Let us see. Now when we see sum of the first 20 terms, what does it mean? What are the first 20 terms? The first 20 terms are 1, 2, 3, comma, 20. Right? Because it says first 20 terms. Confirmations that this is clear. Why we are writing like this only? 1 to 20. Okay. We already know that this is an AP. Now in an AP, there definitely is a T1. Tell me what is the T1 here? What is the T1 here? 1 is correct. Every AP has a D, common difference. What is the D here? That is also 1, correct. And because this is a finite AP, our last term T20 is equal to how much? What is our last term? Very good. It is 20. Right? Now look at the third formula. Look at the third formula for sum of first n terms of the AP. Third formula says it is Sn equals to n by 2 T1 plus Tn. What is our n here for this AP? How many numbers are there in this AP? How many terms are there? You will tell, I will write. Yes, it is 20 by 2. What is our T1?
1.
What is our Tn?
20.
What is 20 by 2?
10.
How much is 1 plus 20?
21.
How much is 10 into 21?
210.
Right? So you can use the formula. Clearly, we can use the formula to find the sum of first 20 terms instead of making this long, doing this long addition. Instead of doing this long addition. Right? Is the same. Now let us try the second formula. The second formula says S of n, Sn equals to n of a, n into a. One second. And the formula continues as second term plus n into n minus 1 by 2 into d. Now we know that we are calculating the sum of the first 20 terms. N is 20, a is 1, n is 20, and minus 1 will be 19 by 2, d is 1. Now 20 into 1 is 20. 190. 210. We can use this formula also. So we can just add the terms to find the sum, or we can use the formula. Now I am asking you to find the same sum using the first formula. Find the sum in your notebook, clearly write it clearly, all the steps, take a picture and send it to me on WhatsApp. Using the first formula, which reads as S of n, Sn equals to n by 2 within brackets 2a plus n minus 1 into d. Waiting for your answers on my WhatsApp. If we use the first formula, which looks like this, Sn equals to n by 2, then there is a bracket 2a plus n minus 1 into. This is what we have to use. Now we know that the main AP is 1, 2, 3, 4, 5, dot, dot, dot. But the smaller AP that we need to work with is 1, 2, 3, dot, 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 20, because it says 20 terms. So from here, we know that T1 equals to A equals to 1. We know D equals to T2 minus T1 equals to 1. Right? So when and n equals to 20. Because we know this, we will put the values in the formula. S20 equals to 20 by 2. Let me write it a little below. 1 second. S20 equals to 20 by 2. So we have 2 into 1 plus n is 20 minus 1. D is 1. Bracket is closed. 20 by 2 is 10. Within brackets 2 into 1 is 2. 20 minus 1 is 19. 19 into 1 is 1. So this comes to 10 into 21, which is 210. So whether we use the first formula, second formula, or the third formula, the sum comes to the same thing, 210. Now, in different situations, we will have to choose which formula we would like to use to find the sum, depending on what we have. what is easy, what is more difficult. But realize that we don't have to add all the numbers. We have the formula that we can use. Not just one, not just two, but we have three formulas. Use the formula that we have learned just now and try to solve this question, which is first question of practice set 3.3. Try on your own in your notebook. First step of the answer is just the formula. So here we can write 2a, nothing more, 2a. In the second step, what happened is someone did this in the brain, in the mind, 2 into 6, which is 12. So 12 यहाँ लिखा है. Now n is 27. So here it is written 27 and d is 3. So we will have to write 3 here. First step is done. Second step is also done. Now what? Someone has again skipped some steps. So हमको क्या करना पड़ेगा? So 27 by 2 within brackets 12 plus 27 minus 1 is 26 into 3. That equals to 27 by 2 within brackets 12 plus कितना? 3618 78. Is it correct? Is it correct? Then we have 27 by 2. This becomes into 12 into 78 is 90. So this is the 90 that we have to write. So when we are writing this kind of answer in our notebook, we will show this step. We will show this step. Now this step is not required because it is the same step. Now we have to divide 90 by 2, which is 45. Now 45 into 27, we have calculated it as 21215. I have not calculated. Please confirm that I have got the product correct. 12 into 27 into 45 is 121. Right? This is how we answer. So many of you have solved. So many of you have solved correctly. Clearing the screen in 5, 4, 3, 2, 1, and 0. Let us try another question. We have identified that a equals to 14, n equals to 100, t1 equals to 14, d equals to 2, and we have to find s100. Solve it in your notebook and send me a picture of your answer. So if we use the first formula, we know s of n equals to n by 2 within brackets 2a plus n minus 1 into d. We have already found out a, n, d सब कुछ. So we can say S100 जो कि इस क्वेश्चन में पता करना है. S100 equals to 100 by 2. Now 2 into 14 plus again n is 100. So 100 minus 1 and d we have found out as 2. Now 100 by 2 is 50. 2 into 14 is 28. 100 minus 1 is 99 multiplied by 2. So 50 is 50. 28 is 28. 99 multiplied by 2 is 198. 50. 28 plus 198 is 126, if I am right. or two, no, not 120, 126, 226. It is more than 200. 226. And you, when you multiply this, answer is 11,300. Right? So using the first formula, putting the values of A, D, and N, we can find out S100 to be 11,300. This is solved in the textbook on page number 69. What we will do in the next class is we will understand how this formula came up. Why S of Sn equals to n by 2 within brackets 2a plus n minus 1 into d. Why we can also say it is equal to na plus n into n minus 1 by 2 by multiplied by d, and why it is equal to n by 2 multiplied by t1 plus t. We will understand that. We will also understand how the summation formula, the sum formula for some specific examples, that is sum of n natural numbers, sum of n even natural numbers, sum of n odd natural numbers, because these are the situations where we don't need to start from the basic formula. We can also use the derived formula directly, and we will look at more and more questions of sum of first n terms. For this chapter, for this part of the chapter, we will need both. We will need the formula for nth term. We will also need the formula for first n terms of NEP. I will update the slide for homework and send this slide to you after the class.